Can you see it now?
Yes. Welcome.
Okay. So I can begin right now.
Yes.
Okay. Nice. Hello, everyone. Thank you for your interest in our paper, Region-based Excavator Activity Analysis and Safety Monitoring System from Baidu Research. First, I want to talk about background and motivation. Operating excavators in a real-world environment can be challenging due to extreme conditions, such as multiple fatalities and injuries occur each year during excavations. Safety is one of the main requirements on construction sites. With the advance of deep learning and computer vision technology, our autonomous excavator system is assigned to load the waste disposal material into a designated area. Well, in this paper, we mainly focus on the safety part. Also, the system can also be generally applied to manned excavators and other construction things. This paper has three main contributions. First, we develop a deep learning-based perception system for multi-class object detection, post-estimation, and action recognition of construction machines and human on construction sites. Second, we propose a novel excavator safety monitoring and productivity analysis system based on the perception system. Last, we collect a dataset from our AES system, including multi-class of objects in different lighting conditions with human annotations. Our network gets SODA results on the AES and the benchmark construction dataset. Here is the system pipeline. Our AES system, activity analysis and safety monitoring system, including video input, perception, monitor, and analysis modules. The input to our system is surveillance camera video. The perception module contains multi-class object detection, excavator post-estimation, working area segmentation, activity recognition, safety monitor, and activity analysis. First, I'm going to talk about the data and the perception modules. The working area are being segmented into digging and dumping area first. Then the detection method is used to identify construction machines and human in video frames. Second, the excavator is identified through post-estimation. Next, the action state of the tracked excavators is recognized with post-estimation, working area segmentation, and action recognition method. So the perception model have these four modules. So our detection module can detect multi-class construction machines, including excavator and loader here, and human in real time. The detection of construction equipment is realized based on fast RCN. To remove duplicate bounding box, we apply the soft NMS to limit max bounding box per object to 1. We collect the excavator dataset from our system from the waste disposal recycle thing. The dataset including 2 hours of videos in different lighting conditions and contain 2 types of construction equipment and human. We also design a labeling method for the fixed excavator as 10 key points. Those key points are excavator parts annotated, which shown in the figure. The segmentation network is based on ResNet. A digging area is defined as recycling area, which including various toxic materials. A dumping area is a designated area to dump waste. Based on the excavator key poses and the area segmentation results, we define the excavator digging, swinging, dumping actions as following. Here we label the 100 clips of excavator videos with 3 actions: stacking, dumping, and swinging. Then we implement learning-based action recognition module based on slow fast. Next, I'm going to talk about safety monitoring and activity analysis module. The construction site safety is monitored based on the previous perception results. Besides, the productivity of the excavator is calculated by the activity recognition results. The autonomous excavator and the loader may have potential collision as figure shows. So it's important to detect potential collision since the loader is hard to know which state the excavator is currently at from his wheel. The danger signal is sent when the autonomous excavator and the loader machine are both detected in the digging area. Besides, our system will send alert when human entering working sites. The productivity of the excavator is based on the action recognition results. The excavator's productivity can be calculated with the cycle time and the bucket payload as shown in the equation. Since the bucket payload is given by the manufacturer, the target of the productivity calculation becomes to determine the cycle time of the excavator. For example, in a video, the XCMG compact excavator complete 40 working cycles, and we can then calculate the productivity and the accuracy. So for the cycle time calculation, the time for each cycle is measured following the workflow shown in the figure. After the action recognition, each video frame is being labeled. Then we record start and end frame of current action. So current action time equals to end frame minus start frame divided by frame per second of the video. Next, we decide which cycle action have ended, which including digging, swing, dumping, and swing in our scenario. If not, then we will continue to record the frames of next action until one cycle is ended. Finally, we will sum up all action times to get the cycle time. Here, we're showing some demo. We collect things including excavator, human, and loader. And here, the multi-class objects is detected in real time. You can see left, there's a human here, and the right, there's a loader here, and there's an excavator in the behind. Here is the excavator detection and post-estimation results on our AES system. Faster ASEAN achieves 92% mean average precision, and the simple baseline achieves 96% average precision. Here the post is detected. Action recognition result on AES and UAE dataset. The experimental results show that our action recognition approach based on slow fast outperforms the state-of-art approach by about 6%. The results are shown here. The number one is top prediction. Here's some more results on UIUC construction data site. In this paper, we proposed a safety monitoring and action analysis system based on detection, post-estimation, action recognition modules. Besides, we collect a dataset including multi-class of objects in different lighting conditions from our system. We also evaluate our methods on a benchmark construction dataset and achieve certain results. In the future, we will extend our perception modules to more construction machines in different scenarios. Thank you for your attention.
Thank you very much, Sibo. That was really good presentation and really nice piece of work you guys did. It's really lovely to see Beidou actually presenting their work in ISARC. We're really excited. Do we have any question from the audience? We can take probably a couple of questions. If not coming quickly, I certainly do have some questions. Where do I start? The first one is, you have a camera that is located outside and monitors a zone. Have you considered putting the camera on the excavator? What are the benefits or the drawbacks of having an egocentric type approach as opposed to what you're doing?
Okay, so this system is focusing on safety monitoring. Putting a camera outside is very easy, cheap, and is fixed camera. We also have for the AES, there is more detail showing in the Science Robotics paper that there is we also have LiDAR on it. Okay. So there's a double system to guarantee the safety. Okay.
The other question I had is, when you do the action labeling, do you consider the sequence of actions in the model? So the fact that you were digging, the fact that swinging should come after digging or after dumping. So is this taken into account, or is the labeling done solely based on the image, as opposed to, you could have some sort of Markov model where you take into account the fact that you've just been digging, so most likely you will be swinging afterwards?
Oh, we use slow fast as our network, and labeling is clips. So it's based on short video, 5 seconds or 7 seconds. Each video is just simple one action and not consider the following one.
Okay. It's just to not be curious. Okay. I'm just not familiar with some of these models. Thank you. I don't see any other question, but I very much enjoyed, and thank you very much for presenting, and well done for getting a plenary presentation today. Great work. Thanks. Thank you, Sibo.
Yeah.
I would like now to ask, is